Okay, continuing with the organic naming then. So we've done straight chain alkanes and the branched as well. What we'll do is we'll have a look at the cyclic now. So the cyclic, as the name implies, the carbons are going to form an actual ring structure. So we need some way of distinguishing this from if I've just got 4 carbons in a row like that, because both of them, 4 carbons, both obviously based on bute, they're all single bonded, saturated in there, so they're based on the alkane. So we've got the butane. So in order to distinguish this one from a straight, then all I do is I put the word cyclo in front of it to say that this is 4 carbons in a ring. So cyclobutane there. Now you can have branches coming off in much the same way that you have branches coming off the straight chain. So I'll just give an example of this one. So if we've got it drawn out like that, then in a case of obviously our ring structure around there, if I just change colour to circle it, we've got the parent here and branches coming off the side there. Now any carbon within this ring you can call carbon 1, so we'll just say there. The rules in terms of the branches from previous still apply, so we need to give branches the lowest possible sum total. So if I call this number 1, if I went anti-clockwise, then obviously it would be 1, 2, 3 around there. 1 plus 3, 4. Better way of doing it, starting there, going clockwise, 1, 2, 3 around this way. So if I go clockwise round, then 1 plus 2, 3, and obviously that's a smaller number. So I've got a 1 methyl there, 2 methyl here, and 3 carbons in the ring, so a cyclo bit. So if we put them all together, we've got the cyclopropane as the parent bit, and obviously the 2 methyls, since they're the same branch, I can just lump them together and say 1, 2 dimethyl. So that's the cycloalkanes. Not much different from the regular straight chain, just remembering that cyclo bit. Now the next one we'll look at, haloalkanes. So the halo comes from within this, we are going to have halogens. So the halogens we know, group 7, we've got fluorine, chlorine, bromine and iodine. In terms of the names we'll be using for those, fluoro, chloro, bromo and iodo. Now the halogens are basically treated as branches, much the same way as methyls, ethyls hanging off the parent chain. So we'll again just jump straight into an example and it's fairly clear to see. And what I'm going to do is just have a alkyl branch in there as well. Right, so parent, longest carbon chain, made it nice and easy, just 3 along there. It doesn't make any difference if I did the third one at the bottom instead. So I've got multiple branches coming off around here. So for giving them their individual bits, well, the parent, 1, 2, 3 carbons. Which side to count from? Well, if I count from the left and I go 1, 2, 3, I've got a branch on carbon 1 and I've got 2 on carbon 2, 5 there. Whereas if I count from the right hand side, 1, 2, 3, Then I've got 2 plus 2 plus 3, 7. So I go with the higher number for that. So I'll be counting from the left. So the longest chain, 3 propane. In terms of the individual bits, I've got a 1 iodo, I've got a 2 chloro, and I've got a 2 methyl here. Alphabetical order still applies with these, with the various branches. So regardless of numbers, so obviously chlorine first. So 2 chloro, 1 iodo, and 2 methyl in there. So purely CIM. So the methyl is treated exactly the same as the halogens for the branches, and you're just looking at alphabetical. So that's the haloalkanes. Now, the next one we'll look at is the alcohols. So this is where we are going to have an OH group. So you'll probably be familiar with the structure of ethanol. Undoubtedly, you'll have seen that at school. And we'll just give a way for where its name actually comes from. Now, 1, 2, 3, 4. Now, on the BTEC, they're not going to be mixing up functional groups in terms of ever needing to really use the alcohol's prefix of the hydroxyl if we've got a carboxylic group in there taking the parent instead. So the main thing that we need to remember here is alcohols end OL. So for the name of this, first off again, longest carbon chain, you always do that. 1, 2, 3, 4, nice and easy round there. Count from the side to give the alcohol the lowest number. So I'm going to count from the right. 1, 2, 3, 4. Puts it on carbon 2 rather than 3. And now for the name of it. 4 carbons, bute. Now, it's based on a general alkane backbone in terms of these carbons are all single bonded to each other. So I keep the AN in there, but I get rid of the E because it's not a pure alkane anymore. Instead, we are now the alcohol. We've got this functional group. So the AN, all carbons, single bonded. And then I need to say where the alcohol is. So I say it's on number 2. And OL because it's an alcohol. At carbon 2. There is an OH group. So the reason ethanol doesn't get the number within it is the alcohol can only be on carbon 1 in that, so it's usually ignored. But longer chains of carbons, you do need to specify where that OH is, because I can have butan 1-ol and I can have butan 2-ol, whereas there is no such thing as ethan 2-ol. Okay, so let's scroll back up. I'm forgetting what we need to cover. So we've done straight chain, we've done branch, we've done cyclic, we've done alkanes, alcohols, haloalkanes, alkenes now. So an alkene is where we are unsaturated. We've got a carbon-carbon double bond within it. Now we'll do a simple alkene first, and then I'll introduce the geometric isomers. Let's just lengthen that off a bit. Okay. So the ending for an alkene nicely is -ene, rather than the alkane being -ane. You look for the longest carbon chain. Nice and easy. So I start with but. Now I need to say where the functional group is. Now what you do, again, count from left and right. You give it the lowest number for where that double bond starts. So 1, 2, 3, 4 from the left. 1, 2, 3, 4 from the other side. But in this case, I've made it nice and easy from the left. So the double bond starts at carbon 1. So therefore, you say this is called but1-ene within there. Now you can have branches coming off them much the same way. So if we just quickly do one of those, I say stick a halogen in. Then this one would be 2-fluoro, don't need a dash there, prop1-ene, because we've got the prop, we've got the 1-ene, and the 2-fluoro up there. So those are the more general alkenes that do not show the geometric isomerism. We'll go through one that does. So we just scroll up to look, because we need to go through this bit there. So we've done the general naming alkenes, but the geometric isomers now. Right, so with this, down the double bond, and what we can see is on the left side, we've got H and a Br sticking off the carbon. These must be different. And on the right side, we've got a CH3 and we've got a Br. These must be different. Does not matter at all across that double bond past this middle line here. You're purely looking on the left-hand side and then the right. Both of the left must be different. Both of the right must be different. If they are not, then you will not have geometric isomerism, which is why, if my screen stops going weird, if we look at the ones above, on the left-hand side in here, hydrogen and hydrogen, they were the same, and likewise across there, so that cancelled out. So for this then, what we do is we use the Carning-Gold-Prelog. So again, I mentioned this in another video. And I give the highest atomic number when I compare atom versus atom, the highest priority. So hydrogen versus bromine. Bromine wins. Bromine 79.9 versus hydrogen 1. So this is the high. On the right-hand side, bromine versus carbon only. So you compare the immediate atom here that is connected to the carbon in the double bond. unlikely you will see it, but if they are exactly the same, say if the bromine was a carbon, then you look at the next highest atomic mass joined to that species and compare those. So it's like a football sudden death thing, but I can't foresee you getting one of those on the exam. So again, bromine 79.9, carbon 12, bromine wins, high priority. Now with the EZ, Z is if the highs are on the same, E is if they are on different. So for naming this, first off, we can ignore the EZ for now. I'd look for the longest carbon chain, 1, 2, 3, prop. Count from the side to give the double bond the lowest number, carbon 1. So prop 1 in. Then I've got these two branches sticking off, the halogens. So they're on carbon 1 and 2. So 1, 2, dibromo. And then as I said, with the Z isomer, if they are on the same side, they're both sticking down here, whereas the CH3 and the hydrogens are up. So the same side, I simply put a big Z in front of it. And then it distinguishes it from, if I just doodle it across here, this one would be the E isomer, and then exactly the same rest of the name. Okay, so yeah, that's everything covered in that. Thank you.